right, hello Algebra 2A students. We're gonna go over the quiz. I think you got this on Tuesday, Exponential Growth and Decay version 1. I'm just gonna do it 2 problems at a time. I'll do 3 videos, 2 problems per video, 2 problems per video. But starting with numbers 1 and 2, and you can see on your paper the instructions that we're supposed to write an exponential expression for each situation, and we're going to use x for the number of years. So I filled that in here. And I just wrote up on the board to remind us that when we're talking about exponential growth, that's referring to an increase, and this is the general equation we can use, and we can talk about what a and r represent. If we're talking about exponential decay, it would be a decrease. Here's our general equation. But starting with number 1, we're just doing expressions for number 1 and 2, so we can actually cut out the y equals part, and we can just fill in numbers into this expression if it's an increase or if it's growth. If it's a decrease or decay, we can forget about y equals there. But let's get started with number 1 here. So we have a situation where we have something that's increasing at 2%, and the current value is $35,000. We're supposed to write an expression for the value of this in x years. So x could be potentially any number, but we basically need numbers for a and r. So I'm just going to write this out. A times 1 plus r to the power of x. X is going to stay as an x, okay? But we need a number for a, we need a number for r. So if you remember, a represents the initial value, or we could call that the current value, or how much there is right now. So that's going to be 35,000. That's going to be a. R is your rate, your percent rate, either of growth or decay, increase or decrease. And so that's going to be the 2%. But remember that when we put it in the equation, I'm not just going to put a 2 here. I'm going to put the decimal or possibly the fraction form. I like the decimal form. So this is r, and in decimal form that's 0.02. So all I have to do is put these numbers in for a and r, and that's it basically. Well, we'll do a little bit of simplifying, but that's the hard part. So a is 35,000, and then the 1 is there. If you remember, the 1 represents your original 100%, but that's the decimal form for it. I'll go ahead and fill in the rest of it here. And then for r, we can put 0.02. So that's basically it. I'm going to do a little bit more with this. Putting the initial value, putting in the percentage in decimal form. The only other thing I'm going to do with this is I'm going to say, hey, 1 plus that 0.02, we can do that. We can simplify that. So I'm going to simplify this whole expression here a little bit. So we still have the 35,000, and then when you do 1 plus 0.02, it's 1.02 to the power of x. And that's it. We're done on problem number 1. Someone now could come to us and say, okay, I didn't know the number of years at first, but now I know it's going to be 5 years. And we can put a 5 there, and then we could calculate what's 35,000 times 1.02 to the 5th power. And we could get a result out. Last thing I'll say about number 1, and then we'll move on to number 2. Remember that we do not multiply these as they are, because order of operations, you can't see it, but you remember the sign, the poster I got above the board. I like to do GMA. We're supposed to do the exponent before we multiply. But since we don't know the value of the exponent, we're stuck. We just go, all right, then that's it. That's our answer. That's as much as we can do, so we're done. Number 2, this one's a decrease, so that's going to be 1 minus r. Again, that 1 represents the original 100%, and then take away what you're losing, take away the decrease. But it's the same idea as number 1, except we're just going to start with a times 1 minus r to the power of x, and say, all right, we need a value for a, we need a value for r. By the way, let me highlight here, I guess, that we're increasing, and here that we're decreasing. That's how I know which one to use. Do I do 1 plus r or 1 minus r? The rest of it is the same. So let's see here. A is going to be our initial value, what we have right now. So that's going to be the 12,000. And R is the rate, the percent. So that's the 7.4, but we want that in decimal form. So we can divide by 100 if we want. That's a quick way to get your decimal, 0.074. I just have to put those numbers into the equation. So A goes in, the expression. A goes in as 12,000. We're still going to have the parentheses with a 1. We're going to subtract that decimal. I'll fill that in here in a moment. And again, in my opinion, the hard part's over. I'm just going to simplify. I'm going to do the operations that I can here. I can do 1 minus 0.74, but everything else will stay the same. So we'll have our 12,000, and this comes out to, I should know that, I believe it's 92.6. Oh boy, 1 minus 0.074. Yeah, 0.926 to the power of x. That's it. Again, if somebody wanted to come and say, oh, I told you X years previously, but now I know it's going to be 7 years or 12 years or whatever, then we could perform the rest of the operations. But that's it for number 1 and number 2. We'll do another video for 3, 4, 5, and 6.